The next method in the downstream processing is drying. It is oftenly one of the methods which is used in the final processings of the product. So it is one of the last stage of manufacturing process. Drying involves the removal of water, thereby making the preparation concentrate. That means it is one of the methods of concentration. Concentration means increasing the amount of desirable fermentation product in the given preparation. So the undesirable material, the content or that its concentration is decreased, and the concentration of fermentation product is increased. So this involves the removal of water from a heat sensitive material, so that there should be minimum loss of viability, or it should not cause any inact it should not cause any activity changes in the desirable fermentation product. Also, the care has to be taken that the nutritional value of the fermentation product, it is maintained, and it should not be destroyed by the temperature which is used for the drying process. Drying is required because the cost of transport, it can be reduced. That means this is a method of concentration. This means that the quantity of the given material, it can be reduced due to removal of water content, and therefore the cost of transport, so it requires less space for the packaging, and therefore its handling and packaging transportation is easier. The material, it can be stored more conveniently in dry state. So it depends, or it is dependent on the type of fermentation product or the category of fermentation product. So the fermentation products which are not destroyed due to absence of water, such type of fermentation products may remain active in absence of water. So the advantage is that due to absence of water, uh, or due to absence of moisture, the microorganisms may not be able to grow. Like it avoids the contamination by fungi, bacteria, or any other relevant microorganism. So drying is also one of the method of food preservation which we have learned earlier in applied microbiology paper. So this is how drying is significant in case of few fermentation products. Much of the water, it is generally removed initially by the processes uh, which we have discussed earlier. The processes like centrifugation, then filtration or filter press. So these processes already decrease the water content of the fermentation product preparation. So this is how these processes are responsible for decreasing the cost of heating which is required during a drying process. Drying, it can be done at high temperature drying, as we know that as the temperature increases, the water molecules gets vaporized, and this is how the water molecules can be removed from the given preparation. Drying at high temperature makes use of the equipments. These equipments are called as contact dryers. So the product is in direct contact with the heating surface or the heated surface. So in this case, the desirable fermentation product must be quite heat resistant to avoid the activity loss. The most frequently used contact dryer is a drum dryer, where more temperature stable biological products can be processed. This is the diagram of a drum dryer, where we can see the components of this drum dryer are this is the steam heated drum. So there are two drums we can see, and these drums are continuously rotating in the direction which is marked by this black arrow. So the solids which are being dried are in contact with the heating surface. So that heating surface is provided by this steam heated drum. So this contact period is very short, and it is approximately only 6 to 15 seconds. So within 6 to 15 seconds the uh, contact has like fermentation product preparation, it comes containing water molecules comes in contact with this heating surface, and within this very short period of time the water molecules get evaporated from the given preparation. This is how these two drums rotate. In one is rotating in anti-clockwise direction, and the other one is rotating in clockwise. Both are rotating in anti-clockwise direction. This is the feed, that means the preparation which is to be dried, it is fed onto the surface of this steam heated drum at the center, so that the preparation will come in contact with the surface of the steam heated drum. So what are the water molecules which comes in contact with this heat obtained from this steam heated drum? These water molecules get vaporized and will rise into the vapor hood. We can see the presence of a scraper blade which is positioned onto the surface of drum, so that when the drum is circulating, these blades will be responsible for the scraping of the dried product, and the dried powder will fall down and which is ready for the collection. So this is the function of the scraper blade, and the dried product will be then collected. This type of drum dryers are frequently used for heat resistant materials for the removal of water content. You can see that these types of drum dryers can also be useful for the preparation of dried powder in case of spores, endospore preparation of bacteria. This is the diagram of this drum dryer. You can see the drums, rotating drums, which are made up with stainless steel like this. This is a more clear diagram. There are different types of versions of these drum dryers. We can see the steam heated stainless steel drums, so rotating in directions. Then the second form of dryer, which also works on the principle of heating, is a spray dryer. Now this is a further advanced modification of the drum drying process. So as the name indicates, spray dryer, so the liquid or the preparation which is to be dried, it is sprayed. That means it is converted in the form of droplets, and then these droplets come in contact with the heating surface, or in this case the steam. So steam and droplets, they come in contact with each other, so that the steam leads to the vaporization of the water particles which are present in the droplets, and the fermentation products are uh, made clear from the water molecules. So it is most widely used for the drying of biological materials when the starting material is in the form of a paste or liquid. This spray dryer, it can be also useful for the biological materials like bacterial endospores, which are quite resistant to high temperature. So that is the most feasible method the for the making of powder of bacterial endospores. So the material to be dried does not come into direct contact with the heating surface. That is the advantage of this technique. Instead, the material, it is converted into small droplets through a nozzle, and these droplets then fall into the spiral stream of hot gas. That means the steam. So steam is generated from the bottom and the droplets are falling from the top. So there is counter current contact between the droplets and steam or the hot gas, which is at 150 degrees Celsius to 250 degrees Celsius, very high temperature, and gets evaporated in few seconds. So the contact between the biological material and the heat, it is just for few seconds, fraction of seconds, and therefore this is how the biological material gets protected from getting deactivated, or there is no loss of activity because the biological material does not come in contact with the heat for a longer period of time. So it prevents the material from being overheated and damaged. So its activity is preserved as compared to the previous drum dryer. This is the diagram of a spray dryer. You can see it is a hood, and at the top of the hood we can see a blue arrow. That is the arrow through which the feed is entering. That means the preparation being dried, which is present in liquid or paste form. It is feed from this top of the hood. It is connected to a spray nozzle. So this spray nozzle will convert the liquid or paste in the form of droplets. So it is coming from the top, and from the bottom red arrow you can see that is the inlet for the passage of hot gas, which is at 150 to 250 degrees Celsius. So this hot gas will rise in the hood and it will come in contact with the droplets which are coming down from the spray nozzle, and whatever the dried material is there, dried material or the product will fall down, and water vapors will rise in, or it will leave the hood from the top. These are the parts of this uh, spray dryer, which is also called as counter current, because the hot gas is moving from the bottom, and the droplets are moving from top. So they are moving in opposite direction, therefore it is called as counter current spray dryer. So the hot gas is allowed to pass from the bottom, and the feed is allowed to pass from the top through the spray nozzle. So this spray nozzle will convert this liquid in the form of droplets which are falling down, and the gas which is rising in the hood. So this is the counter current contact between the droplets, water droplets containing fermentation product, and the hot gas. So this is how the water molecules will get converted into vapor form and they will rise, whereas the product, it will fall at the bottom, the dried product. This is the working of countercurrent spray dryer. These countercurrent spray dryers can be as big as like this, 7 to 10 feet. This is used for the industrial scale drying process for bacterial preparations and different biological preparations. This is again a very big one, which is approximately 10 to 15 feet, which is a large capacity spray dryer. That is all about the drying at high temperature. Now, as we know that water molecules evaporate or they vaporize not only at high temperature but also at very low temperature, means below freezing temperature. So this process of removal of water at low temperature, it is called as freeze drying. Comparatively, freeze drying process is more costly as compared to the spray drying process or the drum drying process where high temperature is used. So in freeze drying process, as the name indicates, the material to be dried, it is frozen and the and water molecules are allowed to vaporize, which are then separated from the given preparation. This is particularly very useful when use of high temperature is not a suitable method for the drying, means extremely heat sensitive materials can be dried by using freeze drying process. That means uh, this process is mostly useful for the drying of bacterial preparations. So this process is also called as lyophilization. So it is an important operation by which water can be removed at low temperature for processing of heat sensitive materials, biologicals, pharmaceuticals, including bacterial cells. We know that most of the bacterial cells are available commercially in the form of dried powder. So these powders are obtained by using lyophilization process or freeze drying. Now, in this technique, the material to be dried, it is first frozen and then it is exposed to a very low temperature, as low as minus 60 degrees Celsius, and this is done under high vacuum at a vacuum pressure of 0.08 millibar in a lyophilizer. This is just an example of the conditions. So minus 60 degrees Celsius and the vacuum pressure is 0.08 millibar, which is quite very high. So why vacuum is required? Vacuum is required for the separation of water vapors which are generated at minus 60 degrees Celsius. So this process is called as sublimation. Sublimation is vaporization from solids. So solids are directly converted into vapors. The process is called as sublimation. So these compounds are then are dried by sublimation process at high temperature. Sorry, at very low temperature and high vacuum. This technique is costly as it was mentioned. The great benefit of this technique that it does not harm the heat sensitive material. This is the lyophilizer. We can see this is the assembly and at the top of this machine there is a glass assembly, or which is made up with fiberglass. This fiberglass, uh, it forms a chamber. So you can see that this is the unit for the generation of vacuum, which is a motor which is connected to a pump uh, through this. It is connected to this machine. This is the machine, and this is the display where we can set the temperature, and we can see uh, this is the glass vessel. So this is the chamber which is closed from all the sides, and which is exposed to this vacuum. So inside this vessel there is vacuum, there is absence of, and this is a place where we can keep the material to be lifeless. You can see here inside there is a flask or tube which is present inside. Apart from that, you can see there are certain flasks which are attached to these nozzles. So these nozzles which are attached to this assembly, you can see here, and these flasks are attached to these nozzles, so it is exposed to vacuum. This is the assembly of a typical lyophilizer. This is the display unit where you can see the ice condenser temperature is minus 60 degrees Celsius, and the pressure, vacuum pressure, is getting built up. It is 0.02 millibar. So very easy instrument to operate. You can see this assembly, and inside this you can see the material to be dried. It is held in this vessel where the vacuum is there, and the condenser and this chamber is having a very low temperature, that is minus 60 degrees Celsius. And this assembly, it also has the nozzles, and these nozzles are for, or these are the special attachments which facilitates the attachment of flasks, which also contains dried the material to be dried. So here you can see the presence of dried material here inside this flask, inside this beaker also, and in this beaker also. So this is how the material is dried.